Everybody, this is Dr. Nigro with the screencast looking at how to decode science word problems. All right, when I look at a science word problem, they tend to fall in two categories. The first, which is what this screencast is going to focus on, are problems that can be solved using formulas. The other problem style that we tend to see are called dimensional analysis problems, where we're going to use the units to solve the problem. Now, the units are very important. Don't get me wrong. I mean, if you're using formulas, you need to know the units, all right? But we don't use a unit cancellation method like we do in dimensional analysis for formula-based problem solving. So when I approach a formula-based problem, I tend to go through a set of steps, and those steps help me organize the information in the problem, select the correct formula to use, and then check my answer at the end. All right, so if you want information on dimensional analysis, please make sure you watch one of my screencasts on my Chem Calculations website. I go through some of those problem styles on those sites. Okay, all right, so let's get started. All right, first thing I do when I have a problem is I read through it and I note the numbers. Well, what do we mean by that? When reading the problem, locate that number and any units that follow it first. All right, I tend to box them in or circle them within the problem. If I have a highlighter, I might highlight them, but these are going to be our clues when we want to go set up our solution. I build a list with any numbers with the units underneath the problem. This is an organizational method for me that's proven very helpful. It helps me stay organized and make sure that I've actually noted all the numbers that are present within that problem. All right, so here's a problem we're going to be working throughout this screencast. A sprinter runs down the track at 10 meters per second. How long will it take the sprinter to cover the 400 meters? All right, so we first start by noting the numbers. So I see one first, 10 meters per second, and then a second one at the end, 400 meters. And I'm going to put them in a small table underneath the problem with the unit. Do not forget the unit. Without the unit, the numbers have no meaning. So you need to include that unit. All right, so now that I've noted the numbers, I want to use those units. So we know that the unit attached to a number tells us what that particular value is measuring. All right, it gives the number meaning. If the number is no unit, then it doesn't really mean anything. I mean, 10 meters is very different than just saying 10. Okay, so that number and the unit are what we need. We're going to use those units to define what that value is measuring and then translate it into a variable symbol so that we can choose a formula in a little bit. So for example, in physics, we use a V to represent velocity, a D to represent distance. We might use an A for acceleration or a T for time. There's all kinds. All right, once we know what each number represents, we're going to put that symbol in our table that's underneath our problem so we know what each of those values is measuring. All right, when you set this up, let me put that up for you so you can see it. All right, you can see I've added velocity and distance in front of 10 meters per second and 400 meters. Now I've included the word velocity and the word distance. You don't need to do that. Just V and D will be fine as long as you know what those represent. All right, now, before I move on, I also like to check my units at this point. If you've got multiple measurements of the same variable, let's say 2 velocity values or 2 distance values, the units need to match. You cannot have one distance value in meters and another in kilometers. They both need to be meters or both need to be kilometers. If you are going to work a problem where velocity and distance are going to be mathematically interacting, they also need to have matching units. So you can't have meters per second for your velocity unit and kilometers for your distance. You need to have meters for your distance. So please check those units before you finish the problem. All right? Once I've used those units and added those variable symbols to my information, I need to figure out, well, what is the point of the problem? What is the problem asking me to find? It's usually spelled out specifically in the problem, either near the end or can really be anywhere in there. All right, I look for key terms such as how or what in the problem, and then a descriptor that follows that key term, all right, such as how fast, how far, what is the acceleration, how much time, what was the speed, because that descriptor tells me my unknown. All right, I'm going to use it to determine the variable symbol for what I am looking for. If it asks how fast, that's going to be velocity or speed. If it asks how far, that's going to be distance. How much? Time would be time. And then I'm going to add that variable symbol and a question mark to the bottom of my information table that's under my problem. All right, so I have my information. I've added my how long, my question. All right, so how long will it take the sprinter to cover the 400 meters? That's a time question. All right, so I add time and its variable symbol t to the bottom of my informational table. All right, now time usually in physics is going to come out in seconds. Unless the problem asks you for a specific time unit, just leave it in what the mathematics will bring out in terms of units. If it asks for it in a different time unit, minutes, hours, then I'm going to need to solve the problem and do a conversion at the end. All right, so now I know what the point of the problem is. I have all of my information organized. It's time to find a formula. All right, so once I've got my information listed out, it should be pretty straightforward to find the correct formula, but you need to be careful. Do not force the formula. All right, there are going to be times where these problems give you tons of information, all right, and you don't always need all of it to solve the problem. So don't pick a formula that's going to incorporate everything unless it also has a single unknown. All right, now, we're talking about simple problems in this screencast. There are going to be situations where maybe you've been given a whole lot of information and you're going to use that information to find an answer, which you then will use with additional information to find the final answer. So be careful for these multi-step problems where you may have to do a little bit of work before you can solve the final answer. All right. So here are some examples of some formulas that we use in physics. V equals D over T. A equals V final minus V initial over T. V average is V final plus V initial over 2, or V final equals V initial plus A times T. All right, so if I look at what I have in terms of information, I have a velocity, a distance, and I'm looking for time. Well, if I go back and look at my formulas, there's really only one choice here. Velocity is distance divided by time. I have two of those three variables, and the third variable is my unknown. All right. There's no point in using any of the other three because I don't know the acceleration or A. I don't have two velocity values, a V final and a V initial. So all of the other formulas have pieces of information in them that I do not have. So I'm not going to use those formulas. I am instead going to use the one that fits my data. All right, up next, the math part, plug and chug. Plug in your known variables into the formulas where their variable symbols are, all right? Make sure you include those units along with those numbers, and now it's all about the algebra, all right? You may need to rearrange your formula to solve for your unknown. Remember that adding and subtracting are opposites. Multiplication and division are opposites. There are instances in some of these problems where you'll have a square and you need to do the opposite. That's a square root, all right? That tends to be as complicated as it gets. All right, but just keep in mind those algebraic opposites when manipulating formulas. All right, plus whatever you do to one side, you must do to the other. Remember, the goal is to isolate your unknown all by itself on one side of the equal sign. All right, so let's get back to our problem. All right, here are the mathematics. We started by showing the formula that we were going to use. Should always do that. All right, I make my students show me the formula before they do anything else, because at the very least, I can tell whether they've picked the correct formula. Once I have the formula, I then plug in the values where they go in that formula. So 10 meters per second equals 400 meters over time. I then start the algebraic manipulation to isolate t. So the first thing I'm going to do is multiply both sides by t. So it will cancel on the right side, and I get t times 10 meters per second equals 400 meters. Then to isolate t, I'm going to divide both sides by 10 meters per second. So it's going to cancel on the left side. And I get 400 meters divided by 10 meters per second equals 40 seconds. Okay? So again, watch your algebra. It can be very easy to go fast, and then you make an algebraic mistake, and then that can get you an incorrect answer. However, the last step of my problem-solving style is to try to catch those errors. I call it analyze your answer. All right, before you move on to the next problem on your homework, the next problem on a worksheet, the next problem on an assessment, look at your answer and ask yourself, does that make sense? That question will catch a lot of small errors and save you time, frustration, and points. All right. So for example, let's say we're working a problem where we're trying to determine the distance that an airplane flies from Boston to Los Angeles. We set up our problem, work our way through the steps, and in the end, we get an answer of 1.25 meters. So you need to ask yourself, does this answer make sense? Is it reasonable that an airplane flying from Boston, Massachusetts on the East Coast to Los Angeles, California on the West Coast across the United States is a distance of 1.25 meters? 1 meter stick plus the quarter of another one. Is that reasonable? Hopefully, your brain says, no, that is not reasonable, which means there's some sort of error in your problem. It is either a math error or a unit error. So you need to go back and check both of those things. All right, let's look at our problem. All right, we had a sprinter that was moving 10 meters every second, and they were running around a track that was 400 meters. Is it reasonable that it took the sprinter 40 seconds to make that trip? I would say yes. 10 meters every second, 400 meters, 40 seconds seems reasonable. So I would go with yes. If I did all this work and I got an answer of 400,000 seconds, I would probably ask myself if that is reasonable. That seems like that guy was going kind of slow for 10 meters per second. If I got an answer of 0.0004 seconds, that seems really, really, really fast. And I cannot imagine a person getting around a track in that small amount of time. So I would say there's probably an error there as well. So make sure you check. Ask yourself if it's reasonable. The other thing I like to do, I like to take my answer and I'll go back up to where I've plugged the numbers in with my unknown, and I'll put my answer in for the unknown. And then I check to see that the two sides of my equation are equal. So in other words, 10 meters per second equals 400 meters divided by 40 seconds. Those two sides are equal to each other. So I know the problem is correct. All right. So that's my approach to problem solving for science problems that involve formulas. Again, I start by finding those numbers, noting those numbers in their units. I set up a small table underneath my problem for organization. I then use those units to define the variables that those measurements represent, list that along with that number and unit. I then find the point of the problem. What is the problem asking to find, and what variable is that represented? And then I find a formula that allows me to use what I have and what I'm trying to find to solve for that unknown. I plug in my knowns and use algebra to rearrange and isolate my unknown to solve for that unknown measurement. And then I analyze that answer. Is this answer reasonable? And if it is, and I check it, the two sides are equal, then I'm free to move on to the next problem. Okay? So I hope that this has been helpful for how to organize yourself when you're solving science problems. Please keep in mind that these are for formula-based problems, but a lot of these steps are also useful for dimensional analysis. Finding numbers and noting those units is going to be invaluable when you're trying to figure out how to solve a problem. Figuring out the point of the problem, also invaluable. All right. And then definitely analyzing your answer at the end. You can ask yourself if your answer is reasonable no matter what type of science problem you're trying to solve. Okay. All right. I hope everybody enjoyed this video. And if you have any questions, please let me know.